This is our project titled Sustainable Automated Farm System. This is a system in which we create an artificial enclosed environment which is able to grow any plant even out of season. It is able to simulate any weather conditions so that we're able to grow plants that may not generally grow in the current weathers. Right now we're growing lettuce, which generally grows in the winter, and it's currently summer in India. To be able to simulate the weather conditions, we are using multiple sensors such as temperature sensors, humidity sensor, soil moisture level sensor, air quality sensor, and with the air quality sensor we're able to measure the amount of CO2 levels in the box. We're also using purple colored lights because purple colored lights help produce more chlorophyll in the plants, because plants only require the blue and red wavelengths of light. Our system also automatically fertilizes all the plants and creates the mixture customized based on each plant. So when a plant is selected, it will automatically mix the amount of nitrogen, potassium and phosphorus, which will be filled in these three bottles, and these are the fertilizers used: nitrogen, potassium and phosphorus. When a plant is selected, the three individual pumps fill in the nitrogen, potassium, phosphorus in the main tank, and this main tank is used to slowly fertilize the soil. We could have used an NPK sensor, but it would increase the cost of our project, and using an NPK sensor would not really give a very large difference in the fertilization of the soil. So it was a more cost effective solution to just fill in the ratio of NPK into the main water and use that water to fill the soil. We are able to control the humidity in the box with our custom 3D printed humidifier, and we also are able to change the temperature in the box by using a Peltier module. A Peltier module is a device on which, when electricity is applied, it gets hot on one side and cold on the other. So we're able to use this principle to be able to cool down the inside of the box. So this is how the user is greeted with the system. When the system is turned on, it asks us to select the plant. So when we press the buttons, we're able to choose any plant which we want to grow. So when we select a plant, it automatically mixes the NPK values and sets the temperature, humidity and soil moisture levels accordingly to each plant. And it can also change the hours of daylight. To control the hours of daylight, we're using an RTC module to keep track of time. So this way, even if the power goes out, the system still knows when to turn on and off the light. As demonstration purpose, I'll be selecting basil. So when I select basil, it will start filling the nitrogen, potassium, phosphorus. Right now we filled water in each of those containers because there's seedlings inside and those do not require any fertilizer currently. So when I select the basil, it will start filling the nutrients. So now I'll be selecting basil. So it's filling the ratios. So it's filled in the three values, and here it shows the ratio. So we have used a ratio of 3:1:2, and it set these conditions currently. This is the inside of the box where we can see the seedlings growing. That's the soil moisture sensor, and these are lettuce seedlings which are currently growing in summer. That is the cooling system we have designed, which is also 3D printed. So the Peltier blows out the hot air from the top and the cold air goes underneath. This air is blown through the fins of the heat sink, which cools down the air and it blows it downwards. One feature of our project is that it has fail-safe features. So for example, if the soil moisture is low within the soil, but the water tank is empty, so instead of using a water level sensor within the tank, which would also increase the cost and would also increase the complexity of the project, we've used basic logic such that when the motor is turned on, because there's low soil moisture, but if there's no change in the readings of the soil moisture sensor and the time has passed over 1 minute, it will show us that water level is low, and we'll need to fill the water and reset the system. So this is a simple way to be able to use fail-safe features. Another feature is that generally in plants, when people design automated irrigation system, they create a threshold level in the soil. So if the water level goes below that threshold, we fill back water until the threshold is reached. But in the natural habitat of plants, this is not how it works. So the plants need to experience a whole range of soil moisture levels, not one constant soil moisture level. So letting the plant experience this entire range helps increase the yield produced. So in our system, for example, if the soil moisture is set to 60% soil moisture level, we let the soil moisture go down to 55, and once it reaches 55, we let it fill up back up to 65%. So this lets the plant experience the entire range of soil moisture. So this would increase the yield produced. Another thing about our project is that instead of water pumps to fill the NPK values, we've used air pumps. The reason why we've used air pumps is because if there's chemicals filled in these bottles and we used a water pump, that would corrode the inside of the water pumps. And generally for applications like this, we would use something known as a peristaltic pump, but peristaltic pumps would be quite expensive. So air pumps are a cheap and cost effective solution. So when these air pumps turn on, they pressurize the bottles, and by pressurizing, we're able to mix the nutrients into the main tank. We've also designed our own custom app which gives us the live readings within the box, and we also have a website which can show us the current plant and the current humidity temperature within the box. So this is the humidification system of the project. So as demonstration, I will be showing the humidification. So this is how it would work, and this would humidify the inside of the box. So all these things automatically turn on and off based on the plant's requirements. Here I can also change the plant I have selected. We also have a germination mode in which we just need to place the seeds inside the soil, and once we press the germination mode, it will automatically germinate the seeds for us. Okay, thank you. This was our sustainable automated farm system prototype.